Good afternoon. All right. Well, let's see. Hopefully, Jade is on her way. So, Tobias, what are you got any big plans for the weekend?
No, I don't think so.
Nothing. How about you, Weston?
Yeah, I'm gonna go hike the Grand Canyon for like the fourth or fifth time. So
Nice. That sounds pretty cool. Well, hopefully you'll take some good pictures. So, and maybe you'll find that perfect tree that will inspire you for that prize-winning um, that prize-winning welding sculpture that you're looking for, that perfect subject. So maybe you'll see that while you're there. So anyway, um, let's see. Okay, so today we've got um, we're gonna do 10.8, which is the Tayler and Maclaurin series. All right. Um, and I'm just kind of stalling for a minute just to see if Jade is going to come. I would invite you guys, both of you, to if you're looking for something to do on Sunday. I don't know, Wes, if you'll be back, but I'm actually preaching an Easter sermon in Joseph City. So you guys are welcome to come see if I preach what I practice. Anyway, it should be a fun time. So anyway, 11:30 in Joseph City. So you guys are invited if you'd like to come. Yeah, I talked to let's see. So some of the Maclauses that are in my trig class, because their grandparents are in my ward in Joseph City. So I'm like, yeah, come visit your grandparents for Easter. And anyway, so we'll see how that goes. But anyway, I thought that might have been Jada coming in there in Hopi, but I guess not. Well, let's go ahead and get started. This is um, not the longest lesson in the world, but it's actually a pretty important one as far as we talked about power series yesterday. The Tayler and Maclaurin series are series that, I mean, if they have names, they're going to be important in math. But I think I told you that Mr. Blake, when he was going to sub for me, he was like, "Oh, I want to teach this." This is, but he decided to stick with the order that we had. But anyway, it's a little bit different, but we'll go with it. All right. Well, let's go ahead and get started. Okay. So Tayler and Maclaurin. So we'll start off with the Tayler series. And if you remember, we had the Taylor's, the power series. Oh, there's Jada. So the power series is where we had x to the 0, x to the first, x squared, x to the third in each term with a constant. Well, with the Tayler and Maclaurin series, we actually also include the derivative now. Okay, so you could even think, well, so the first we have, let's see, this is kind of what you can write this down, the summation, but this is actually the series part that you have to have. So you start out with the value of the function at A. Now, and I'm going to skip the rest of this for just a second and just show you in each term, the first term has the f of A, the second term has f prime of A, the third term has f double prime of A, and then f triple prime of A, and so on. Okay? Then you have the factorials, just like we had before. So in the first term, you have 0 factorial, then 1 factorial, 2 factorial, 3 factorial, and so on. All right, and then this series is generated at x equals a. So the first term has x minus a to the 0, and then x minus a to the first, x minus a squared, and x minus a to the third, and so on. And so the nth term would be the nth derivative evaluated at a over n factorial times x minus a to the n. Now, the dots at the end here mean that this is an infinite series. It goes on forever. Okay? Now, to me, what's fascinating is that you can take functions like cosine of x or e to the x or whatever, and you can write them as a Taylor series. Okay? And so that's what we're going to do. Okay. So let me give you the first example. So let's say we have, here's our function 1 over x. And we're going to evaluate it at a equals 2. All right, so the Taylor series says, to set it up, what you want to do is take the first, usually the first 3 or 4 derivatives, and then plug in the value, okay? That's going to be our coefficients. So if f of x is 1 over x, the f of 2 is just 1 over 2. All right, the derivative, f prime of x, is negative 1 over x squared. So then when we plug in 2, we get negative 1/4. All right, the second derivative is 2 over x cubed. And then we plug in 2 and we get 2 over 8, which simplifies to 1/4. And then finally, the third derivative is negative 6 over x to the 4th. We plug in 2 into that and we get negative 6/16, which simplifies to negative 3/8. Okay, so I just took the first 3 derivatives and plugged in the value that I was given. That's kind of part of the setup. But any questions so far? Okay, so now we actually set up the Taylor series. So it's going to be the f of 2, and so I'm going to plug that in, over x minus 2 to the 0 over 0 factorial, plus the f prime of 2 times x minus 2 to the first over 1 factorial, f double prime of 2 times x minus 2 squared over 2 factorial, plus f triple prime of 2 times x minus 2 cubed over 3 factorial, plus, and then the nth derivative evaluated at 2 times x minus 2 to the n over n factorial. Okay? So this is what's known as the Taylor series. Okay? Now, when I plug in and simplify, then that's going to be our Taylor polynomial. Okay, so next I'm going to take and plug in. So for the f of 2, I have 1/2 over 1 times 1, so I just get 1/2. All right, the next one, I have 1/4 times x minus 2 to the first, so x minus 2 over 1. The next one, f double prime of 2 is 1/4 over 2, so that gives me 1/8 times x minus 2 squared. And then the third one, let's see, we had negative 3/8, and then we also have a 3 factorial, so that's going to simplify to negative 1/16 times x minus 2 to the third. And so that's the Taylor polynomial right there. All right, any questions on that? Okay, so what I would like you to do is, so I want you to do this first part. This just setting up the Taylor series, okay, for practice 1 there, okay? Okay, so this is a little messy, but just the initial setup is the Taylor series. So it's the f of pi halves times x minus pi halves to the 0 over 0 factorial. And now these two will simplify out. Plus the f prime of pi halves times x minus pi halves to the first over 1 factorial plus f prime of pi halves times x minus pi halves squared over 2 factorial plus f triple prime of pi halves times x minus pi halves to the third over 3 factorial plus dot dot dot. Okay, maybe it'd be good to go one more f quadruple prime times x minus pi halves to the fourth over 4 factorial. Okay, so just kind of the setup like that, that's the Taylor series. Okay, I'm going to have you simplify it in just a minute, but any questions on the setup? Okay, so we'll come back to this. All right, so the Taylor polynomial of order n, that's when you go through and simplify it, and n tells you where to stop, basically. Okay, so like if it's of order 3, then you stop at the third derivative. Or if it's order 4, you stop at the fourth derivative or whatever. Okay, so of order n. All right, so for practice 2, then what I want you to do now is go back through and simplify this, and it says go to the order of 4, degree of 4. So that means you got to go through the fourth derivative, okay? And then simplify. Okay, so when you're plugging in to the Taylor polynomial, you need to find these first four derivatives and then plug in pi halves. So you're going to get 1, 0, -1, 0, and 1 for those. Okay? Everybody okay with all that? The derivatives and plugging in. Okay, so now all right, let's go back. Okay. Okay. Let's see. I'm not sure where that goes. Okay. So then we have, so every other coefficient is going to go away. So in the first one, we just have 1. Everything just becomes 1. Then the second one, we get 0 times whatever, x minus pi halves. That's still going to go to 0. Then we have 1, times x minus pi halves squared over 2 factorial, which is 2. And then, see, the third one's going to have a 0 on it. And then the fourth one is 1 times x minus pi halves to the fourth over 4 factorial. And then when we simplify, get rid of the 0 terms, we just get 1 minus 1/2 x minus pi halves squared plus 1 over 24 times x minus pi halves to the fourth. Okay? So that's the Taylor polynomial of degree 4. Okay? So did y'all get that? Yeah? Okay? All right. Now, so this is, if this was at x equals pi halves, okay? The first one I did was when x was, or a was at 1 or 2 or something like that. Now, there's a special, let's see here. Okay. So there's a special kind of Taylor series that's called the Maclaurin series. Now, what the Maclaurin series is, it's just the Taylor series at x equals 0. Okay? So generated by, when you evaluate the function, the derivative, everything, you plug in zeros into all those values. So it's the f of 0 times x to the 0 over 0 factorial, f prime of 0 times x to the first over 1 factorial, f double prime of 0 times x to the second over 2 factorial, and so on. So it's the Taylor series specifically generated at x equals 0. Okay? So, but this is kind of the formula here. Okay? All right. So this says what just happened? That was weird. It just closed down. Let's see if we can. Okay, well, let's see if you can do practice 2. Okay, or practice 3, I guess it is. So find the Maclaurin series generated at f of x equals e to the x at x equals 0. So I actually want you to write the polynomial too. So not just set it up, but then I want you to simplify it. Oh, it doesn't say the order. So usually what I tell my students is to go to degree 3. Okay? So let's just put this of degree 3. Okay, so let's start with a lot of times I'll actually start off just taking the derivative and plugging in. Now the cool thing about e to the x is it's its own derivative. So the derivative of e to the x is e to the x. And then when we plug in 0, all e to the 0, anything to the 0 power is 1. So they're all going to be 1. So this is like the Maclaurin series. So where we're setting it up. Okay. And now when we plug in, see we get the f of 0 is 1 times x to the 0 over 0 factorial plus 1 x to the first, okay, because remember there's a little exponent of 1 there, over 1 factorial 1x squared over 2 factorial plus 1x cubed over 3 factorial. Okay, and then you can put the dot, dot, dot because it just said go to 3. And so then if we simplify that, our polynomial will be 1 plus x squared over 2 plus x cubed over 6. Okay. So did y'all get that? Kind of? So Tobias, where did we lose you on that?
Well, I was doing it right, but when I started getting one over and over again, and then I had to plug in, I was like, okay, I think I'm doing something wrong because I didn't think I could do that. So I just kind of stopped, but I was on the right track.
Okay, so here's the thing that I want you to understand, the kind of the importance of what we just did is that we actually took a function e to the x and are writing it as a polynomial. Okay? That's a huge idea, that you can take a function like e to the x and write it as a polynomial. All right? Now, it turns out that things like cosine of x, sine x, all of those we can write as polynomials. Okay? That's the big deal. Now, so on Monday, okay. So again, you need to practice on these. I fear that you're not practicing enough, and then you go take the quizzes and whatever, and then if you haven't had enough practice, then you won't remember how to do it on the test or the final. On the guided notes, I've only got 4 problems here for you to practice, because just setting it up and so on. But you need to work on it. Now on Monday, what we're going to do is now kind of combine the idea of these power series, the Tayler and Maclaurin series, and what we've been talking about the last couple of weeks about convergence. And so we're going to talk about, well, do these series converge, and how do you figure that out? Okay? So, but that's all I've got for today. Any questions?
Here, Weston can go first, because my question isn't about the section.
Yeah, mine isn't either.
Oh, okay.
All right. Same thing. I was taking the 10-4 quiz, and there was one of the questions, I don't know, it was kind of like in a different format. I don't know. It was different from the other questions, and it said like half the question, and then it just cut it off. So I didn't know like what the end of it said.
Okay.
And I haven't done it yet, but I just wanted to let you know that.
If you wouldn't mind just shooting me an email to that effect, and then that will remind me to take a look at that quiz. What happens sometimes is as they upgrade the Moodle, sometimes the links where like maybe I've uploaded a picture or something don't upgrade or don't update too. And so if I could easily have lost that. That's happened more than you know, especially in calculus, where the equation editor doesn't have the calculus symbols. And so I'll like take a picture of the problem and then upload it, and then it loses that. So, but if you could send that in an email, I'll take a look at it and see what I need to do. Okay. All right. And Weston, what was yours?
Some of the trig students here are wondering if you'll be teaching calculus next year.
I am. I am going to be teaching calculus. They're working on the schedule right now. But and so what they need to do, if they want to make sure that I teach it at St. John's, then you know how like you lobbied for it. If they will lobby, whoever your administrator is, see what they do is they actually pick the classes, the talent classes that they're going to offer. And if they have 1 calculus student and 7 Spanish students, then they're going to go with Spanish. Okay, and I get that.
Yeah.
But yeah, so they need to lobby and say, okay, now you have a better shot at it because, I mean, they do, because St. John's is in this slot now. And so normally what I've noticed is that they keep the slots.
Okay.
But it wouldn't hurt for them to tell the guidance counselor or principal, or I don't know who makes that decision at your school, but they just need to tell them, hey, we want to take this talent class and whatever. But I'm pretty sure that the calculus, at least the tentative schedule I saw, had the same schools, same time. But this won't affect any of you guys, but in 2 years, they're going to be changing the schedule quite a bit.
Okay.
But we don't need to worry about that yet. Now, speaking of the schedule, one thing I did get yesterday, my official summer school schedule. And so if any of you three want to take Calc 3, it is half tuition over the summer. And MPC's tuition is already the lowest in the state. So I would highly recommend it. Okay, I know Tobias, I know your sister's glad that she took it. And she actually got a better grade in Calc 3 than she did in Calc 2. And it was kind of interesting because she was struggling a little bit in Calc 2, but she was kind of like a rock star in Calc 3. So that was pretty cool. So anyway, but think about that. Monday and Wednesday, it meets from 5 to 9 approximately. Okay. So it is a 4-hour class, 2 days a week. So anyway, anything else before we call it?
My game is Tuesday. You asked me to tell you that yesterday, and I figured
Your
out
game is Tuesday?
next week.
Next week? Okay. Are you guys going to be here Tuesday? Jada? Weston, you think you'll be there Tuesday?
Yeah, I should be.
Okay. All right. Thank you. All right. Well, you guys have a happy Easter. Don't eat too much chocolate bunnies. Okay. We'll see you. Have a good weekend.